In this video, I will actually be showing you how to write equations for perpendicular lines. It's very similar to writing equations for parallel lines. We just have to remember that perpendicular lines do not have equal slopes. Remember, they have slopes whose product is -1, and in order for their product to be -1, the slopes have to be opposites and they have to be reciprocals. So in this example, we're going to write an equation for a line that's perpendicular to y equals 3x minus 8, and the line that we're writing the equation for has to pass through 3, 1. So again, it's important for you to make sure that you take note of what it is that you know about your line, okay, the line that you're writing an equation for. So I know for my line, the line I'm writing an equation for, it passes through 3, 1. So 3, 1 is a point on the line. And I also know that my line is perpendicular to this line. So since they're not parallel, they don't have the same slope. Since they're perpendicular, they have slopes that are opposite. This one has a positive slope. My line will have a negative slope. And not only are they opposites, but they are reciprocals as well. I know there's a glare up there, but that word says reciprocals. So this one's a positive 3. Mine's going to be a negative, but it's going to be the reciprocal of that. So the reciprocal of 3 over 1 is 1 over 3. So those are the two facts, and the only two facts that I need about my line to be able to write an equation for it. I'm going to use point slope form again, just like I did for parallel lines. And I'm going to write y minus y1, well my y value in my point is a 1, equals slope, which is -1/3, times x minus x1, which is the x value from the point my line goes through. All you need to write an equation of a line is a point and a slope, or to be able to get those things. So now I'm going to distribute my slope. Which will be -1/3 x. A negative times a negative will become positive, and 1/3 times 3 would be a 1. And now I have to move this 1 over to the other side of the equation so that I get y by itself. This is going to shake here a little bit, sorry. Okay. And now I have y equals -1/3 x. 1 plus 1 is plus 2. So this line, if I were to graph it, would intersect this line, and where they intersect, they would create 90 degrees. One of them has to be increasing from left to right, one of them is decreasing from left to right. Okay, one thing that I want to make sure that you realize too is if the equation that you're starting with is not in slope-intercept form, you're going to have to do some manipulating to get it into slope-intercept form. For example, if I said that I wanted to know the equation of a line that was perpendicular to the line whose equation is 2y equals x plus 5, and passes through the point 2, 1. Okay, and then I ask myself, well, what do I know about my equation? Well, so far I know that my equation goes through 2, 1. And I might look at this and say my slope is 1. But this equation has not been manipulated yet to get y by itself. So I'd have to do a little bit of extra work. Divide both sides by 2. This will simplify to 1. And now I see that this line has a slope of 1 over 2, or 1/2. Therefore, my line is going to have a slope that's positive. I'm sorry, this one's positive. Mine will have a negative slope, negative, and I have to find the reciprocal of this. Well, the reciprocal of 1/2 is 2 over 1, or just in this case 2. So now I have all the information that I need to know about my line, and I can go to point slope form. Y minus the y value from my point, which is a 1, equals slope times x minus the x value from my point, which is a 2. Distribute the slope, negative 2x plus 4. Add 1 to both sides, and I get y equals negative 2x plus 5 for the equation of the line that would be perpendicular to what we had originally, which is now y equals 1/2 x plus 5/2. Slopes are opposite of each other. The slopes are reciprocals of each other. These two lines would be perpendicular to one another. Okay, your turn to practice.